So, definite integrals, all right? So let's just jump right in here. Nothing really new. So let's find the area under the curve of f on the interval (1 to 4), closed interval from 1 to 4. Okay, 1 to 4. Okay, so we're going to find the area under the curve of f on the interval from 1 to 4. So, okay, typical kind of thing, right? When we want to find area under the curve, we're going to use what? Yeah, or we're going to use an integral. We're going to use an integral, right? We're going to integrate something, right? To find the area under the curve, we're going to be integrating something. So we need our function. Let me give it the function here. So f of x is the piecewise function 2x squared minus 5, and that's for x values less than 2. And then 2x minus 1 for x values greater than or equal to 2. All right. So back when we learned about derivatives, and specifically taking derivatives of piecewise functions, it was pretty easy, right? To take the derivative of this, to find f prime, you just take the derivative of what? The individual pieces, right? Individual parts. To do the integral of this, though, all right, we could, I guess, kind of integrate both things, but then it's like, well, we're on an interval, though. So, how should we go about doing this with our interval? How can we do this? Because we want, so basically, when this is saying find the area under the curve of f on this interval from 1 to 4, that means we want to integrate from 1 to 4 of f, right, with respect to x.
Would you do 1 to 2 and then 2 to 4?
Okay, so Ryan says, would you do 1 to 2 and 2 to 4? Ryan, why are you breaking up the interval from 1 to 4? Why are you breaking up to be 1 to 2 and then 2 to 4?
Because the piecewise function is broken up at 2.
Yeah, so the piecewise function is broken up at 2. It changes at 2, does it not, right? So for the 1 to 2 interval, okay, Anna, which one of these two functions should I be using? For the 1 to 2 interval, which one of these two functions deals with x values between 1 and 2? The first one, right. How are you able to tell that? Yeah, x value is less than 2, exactly right. So for this piece, for this interval, we're going to integrate, whoops, and I put a plus when I should just mean a minus, right? That should be a minus 2x squared minus 5 plus, and then we'll add to that the integral from 2 to 4, and then Anna, what should we put in this one? Yeah, and I forgot my dx there. And then, yeah, it's 2x minus 1 dx. Exactly right. Okay, and that yields then what we're looking to do. All right, so piecewise functions, you just got to break it up over our interval. Okay, break it up where the piecewise function breaks up. All right, and so then we have to integrate both these pieces. So let's see here. If we want to integrate that first piece, let's go to, pick someone I haven't talked to yet. No, all right, just talk to Anna. Caleb! All right, what's the integral of 2x squared minus 5, Caleb?
2/3 x cubed minus 5x.
Okay, 2/3 x cubed minus 5x. Yep, 2 over 3 x cubed minus 5x. We're going to evaluate that from 1 to 2, and let's go ahead and integrate the other piece there. What's the other piece? What's the integral of 2x minus 1 going to be? X squared minus x, and again evaluated from, in this case, 2 to 4. All right, very good. And so we plug it in. So 2/3 times 2 cubed minus 5 times 2. That's 5 times 1. So there's the first one. Okay. And then we're going to integrate that second one there too. Okay, so plus, and then the integral, the evaluated antiderivative here. Uh, 2 squared minus 2. So there it is. Now again, if this were a free response question, you're done. Excuse me. Oh my goodness. Okay. So, I'm going to simplify this though, right? Because we can. So let's do that here. So again, we're going to simplify this whole thing. So let's see, 2 cubed is 8. 8 times 2 is 16, so it's 16 thirds. 5 times 2 is 10, so minus 10. Minus 1 cubed is 1 times 2 thirds is 2 thirds. Minus 5. Plus 4 squared is 16, minus 4 is 12. 2 squared is 4, minus 2 is 2. Okay, so let's see, so this minus in front of the parentheses here, so it becomes plus negative 2 thirds and then plus 5 there. So minus the quantity, because I just made it plus and then distributed the minus sign there. 16 thirds minus 2 thirds is going to yield 14 thirds, and then I'm going to go ahead and combine all these whole numbers together too, or integers I guess together. So negative 10 and 5 is negative 5, negative 5 and 12 is 7, 7 minus 2 is 5.
Now yields negative 14 thirds. Yeah. Should be negative 14 thirds.
Negative 14 thirds.
Yeah, because negative 30 thirds plus 2 thirds.
Oh, okay, I see what you're saying. I'm not done yet. Okay, gotcha, okay. Oh, it should be negative 5 then. Okay, sorry, hang on. Negative 10 plus 5 is negative 5. Negative 5 plus 12 is 7.
Wait. What are you doing?
Go back.
Stop.
Plus 5.
Great.
Yes, but
16
But that 14 thirds should be negative.
Wait, did you combine the 2 thirds and the 16?
Yeah,
Oh.
I combine those together because we're.
oh, you're adding all the fractions.
I combine the like terms of the fractions. Yeah.
I don't like that.
I got super confused.
Sorry, did I jump too many steps there at once?
No, I just like
No, you just
different.
did, you just did it differently.
Just gonna make everything.
Well, I thought these were nice fractions. They both have the same common denominator. Oh, okay. So you made everything into thirds.
Yeah.
Basically, okay. Let's do it that way then. Okay. Yay! Actually, wait a minute. No, just kidding. All right. So minus 30 thirds, negative 2 thirds, plus 15 thirds, plus 36 thirds, minus 6 thirds. Okay. So yeah, 16 minus 30 then is negative 14 thirds. And then negative 2 thirds plus 15 thirds is negative 13 thirds. Ooh, okay. And then plus 36 thirds minus 6 thirds. So I get, let's see here, negative 27.
Wait, no, that negative 13 should be positive.
Positive 13? You're right, positive 13 thirds. Okay, shoot, okay.
We seem a little off your game today.
I am just working through problems right now. No, okay, negative 1 third, okay, and then plus, and I'll go ahead and combine these two together. So 30, well, actually, no, I shouldn't do that. Never mind. Okay, 35 thirds minus 6 thirds equals 29 thirds. There we go.
That was laborious.
Wait, the answer was 29 thirds?
Yeah, that's exactly what I thought.
Or 9.
29 thirds.
Oh, you.
Yep, or 9.666666666 repeating. Okay, so 29 thirds there, right? But again, free response question, you're done here. Otherwise, you need to simplify down to the 29 thirds there. Yes, that arithmetic is important. Okay, so did anyone have any questions about all that fraction arithmetic we just did? We're all comfortable with that. All right. We are going to introduce one new topic today, one new concept, okay, and that is the average value of a function. Average value of a function on an interval. Okay, so average value of a function on an interval. If
these like trend lines?
F is not quite. I'll kind of like try to describe what it is. If F is integrable on the closed interval AB, then, okay, so if F is integrable on the closed interval AB, then, okay, the average value of F is 1 over b minus a times the integral from a to b of f of x dx.
Who figured that?
Who figured that out, right? So you can find the average value of a function now over an interval. So normally to find the average of something, right, you add it up, you add up the numbers and divide by however many numbers you have. Okay? It's kind of hard to do when you're talking about a continuous function and you have an infinite number of numbers to add up, and then you have to divide by infinity because there's an infinite number of numbers that you're, counting up there. Right? But using integration, we can actually find the average value of that function over a particular interval. Okay? So that's the idea. Now, this is very easily confused with average rate of change, something we learned way back at the beginning of derivatives and things, right? Average rate of change, how do you find the average rate of change of a function?
That would be the average.
F of b minus f of a over b minus a. It's the slope formula, right? Okay? And then the instantaneous, we use that to then jump us into the derivative, which is the instantaneous rate of change, right? So that's what you take the derivative, plug in a point, and you get the instantaneous rate of change. Average value is this, though, okay? So average rate of change, slope formula. Average value is the integration thing. Okay? One thing you're finding an average rate of change, here you're finding an average value. Alright, so let's find the average value. And I think I should have enough space here to do this. I hope. Find the average value of f of x equal to, and we'll just stick with 3x squared minus 2x over the interval from 1 to 4. Okay, so according to our formula here, I need to have a coefficient of 1 over b minus a. So in this case, I'm going to write 1 over, what's my b? 4, right. It's my upper limit of integration, minus, what's my a? 1, right? It's the starting point of my interval. So that's like my a, that's like my b. Okay? And then we're going to integrate from 1 to 4 the function 3x squared minus 2x dx. All right, so let's integrate that. So let's see here. So Connor, what is the integral of 3x squared? When we integrate 3x squared, what do we get? X cubed, yeah. And then what's the integral of minus 2x? Yep, just minus x squared. And then in front of that, though, we should have a 1/3, right? 1 over 4 minus 1 is 1/3. So the coefficient just kind of comes along for the ride here. And then we're going to evaluate that from 1 to 4. All right. And so let's see here. It'll be 1/3 times, and then it's going to be 4 cubed minus 4 squared minus 1 cubed minus 1 squared. Okay?
For me.
No. It's for James. Okay, so we'll finish here. Let's see. So it's still the 1/3. Let's see. 4 cubed is 64. Minus 16, and then 1 cubed minus 1 squared will just be 0. So it just leaves that. Let's see here. 64 minus 16 is 48. And then 1/3 of 48 is 16. Thank you. So 16 should be your final answer. Now let's look at this visually and kind of try and see if we can make sense of this. So let's look at the graph of 3x squared minus 2x. And let's look at it specifically on the interval from 1 to 4. So I'm not only going to, can you guys see that okay there if I adjust it there? I'm going to adjust my window to only look on the interval from 1 to 4. All right, well, clearly I need to increase my y values, right? From 1 to 4 there, it's going really high. So I'm going to increase my y values up to, let's try like 20 maybe and see. I need to go even higher than that, all right? So let's try maybe 50 and see that. Okay, so maybe let me try 40 and see if I can get that to work.
What's your minimum?
Minimum is -3, so I could do 0. It's just -3.1. So I can make it -3 or something. Okay, so there's a graph of that region, and we're trying to find the average value here. So if you look, okay, so what are we doing when we find the average value of this function on this interval? So let's just consider the function on the interval in the first place, and then let's try and imagine what that means by the average value. So what that means is from 1 to 4 here, we have all of these y values, right? An infinite number of y values, really, from 1 to 4. And then what I'm doing is we're going to add up all those y values. So that's one way you could do it, right? To find the average, you could add up all those y values, there'd be an infinite number of y values, and then divide by, well, infinity, in a way, and that would give you an average value. Okay? So, average typically means where is that located? If we put our data in order from least to greatest, where is that normally located then for the average? Roughly in the middle, right? So let's see what happens here. What did we say our average value was going to be? 16. So let's graph 16, which we're saying is our average y value, and look at where it is. Roughly in the middle of our data. Okay, roughly in the middle there of the y values. Oh, I'll go back here, sorry. Window x min, x max 1 to 4, because we're only considering the interval from 1 to 4. Okay, and then the y max I had to increase because I didn't see the entire region there. Yes, Anna. I'm just trying to give you, conceptually what's really going on here, which a visual, another way to see it besides just like, oh, here's this random number that Ms. Wimmer wants me to calculate. You can kind of see this is taking up all these y values, averaging them together, and so 16 roughly in the center there.
Is there any way to calculate the midpoint of a line on the calculator?
Midpoint of a
Like of
line.
a curve, like we're here, for example?
Oh, a midpoint of a curve? Yes, but not with what we're going to be learning. You can find the length of an arc, like the length of a curve, and then you would be able to find the midpoint by showing half of it, I guess.
Yeah.
But yeah. Okay. So that's average value. Now, like I said, that gets easily confused with average rate of change, but they are actually related, and let me show you that they are related here. All right. So we're going to do some particle motion. Ew.
New page.
Okay, particle motion. A ball is fired
Sounds like with the moth is fun.
From
30 degrees
from a
angle
cannon.
Off a building 20 meters high.
Yeah. His is more complicated, though. And its motion can be modeled by the function, or I should say by the position function.
That would be I. The I function.
Oh, did you use those?
Yeah, I did. I don't think you have to.
F of t equals negative 16 t squared plus 48 t plus 10. By the way, t is in seconds, and f of t is in feet. Yes, we're using those standard measures, not the metric measures. All right. So I'm going to have us find the average velocity of the projectile on the interval, closed interval 1 to 3, including 1 and 3, using, and we're going to do it two different ways. The first way, I'm going to have you guys do this on your own because this is something we know how to do. Find the average velocity from the position function. Okay, so this is something we knew how to do before today. So go ahead and do that. So we want to find average velocity using the position function. Okay, how is the velocity related to the position function? Right, okay, the velocity is the rate of change of the position. So instead of me asking you to find the average velocity, I could have just as easily said, find the average rate of change of the position, right? Velocity, keep that in mind, is the same thing as the rate of change of position. So you can use the average rate of change formula, which was what Jack just mentioned, right? So you should be able to do it that way. So that's what you're supposed to do here. Average rate of change formula, like Jack had mentioned earlier. Okay. Yes, negative 16 t squared, yes. Okay, also give me correct units too, please, for this, because we are in a context. So what would be the correct units for an average velocity? Okay. Okay, so that is finding the average value. What I just showed you, right? So there's two, like, I don't want to say this, like the two like average things that we know, average rate of change and average value. They are related to each other. So and all you want to use, whichever one you want to use, it depends on what you're given. So here in this problem, we're given the position function. We want to find average velocity. So to do that, that's not average value. You use average value. If I asked you what's the average, if I asked you what's the average position, and I gave you the position. So I gave you position and asked for average position, that's average value. If I gave you the position, I want the average velocity. Velocity is the rate of change of the position. So you have to use the average rate of change. Just have to be what I say. Okay? So that changed this one. Alright, good. Figure that you James on it. So no, for this one you don't, not for the way I'm asking you to do it first. For this one, I want you to find.
Did you get negative 30?
Yes.
Right.
Okay. So
Well,
you
should
should have
have
a
been
B minus F
negative
later, B minus N.
Should have been negative
This is
44.
Yeah.
You get negative 32.
Well, negative 16 plus 48.
Should be negative 16 out there.
Yeah, that's
So
what I
when you
got.
combine those,
Oh, yeah,
you
yeah.
subtract.
Yeah, I got it. I got
Or, wait,
negative 16.
no.
You should get.
Oh, don't plug into velocity.
Oh.
Yeah, you don't need.
F of B, you want to plug into the function.
Okay.
Yeah, did you use the velocity function?
Yeah.
I mean, that's just the position function. You don't need
Nope.
the derivative.
Not yet. The next one we're going
Because,
to.
yeah.
The next method we're going to do it.
Okay.
You don't need the, you don't need the velocity function.
This is not an easy concept to wrap your mind around. This similarity is not an easy thing to kind of wrap your mind around. So I want to take the time here to really, look
Why
at
does
this.
it stack?
It's stanky.
It's the... Well, there's no time to press. What's this? If you're doing order something, you have to do it anyway.
You're supposed to just like, if you're gonna order something, you're supposed to just like leave it in your
Yeah, well, I've looked into my car for like 2 weeks, but there was only one left. So, I just cut off on that.
Oh, word.
Yeah, did they change time guarantee? Not 3 to 5.
What did you plug in? Where did you plug that 3 into? Function F?
Yeah.
Oh, it's negative 16, not negative parentheses. Sorry, guys. Yeah, that's negative 16, not a parentheses there. You're right. It doesn't make a parentheses. Gosh, it's Mr. Whitmire's bad handwriting. That's not the other people said the same. Well, anyway, there's the answer. Okay, but it's negative 16, yeah.
One moment.
Okay, so we should have gotten here negative 16 feet per second. All right, negative 16 feet per second. So questions on any of that?
So we did something like a couple units, right?
This is from, like way back, maybe like unit 2, I want to say, or something like that, for us at least, Right. Okay, why did we use this? We just talked about average value. Why didn't we use average value here? When you are using average value, you are finding so whenever you do average value to something, you're finding the average value of that something. So for example here, if I did the average value formula to this, I would be finding the average what? If I use average position. No. If I apply what I just taught you guys, the average value function, where I showed you the formula 1 over b minus a times the integral from a to b of your function. Okay. If I use the average value formula on something, that means I'm finding the average value of that thing. So average value applied to this, I'm finding the average position. The question, though, said to find the average velocity from the position function. So, given the position function, I want to find the average velocity. Does it make sense now that we wouldn't use the average value, because average value applied to this would give me an average position? That's not what I wanted. I wanted average velocity, which is the rate of change of the position. So, to find the average rate of change of the position, given the position, I need to use the average rate of change formula. The slope formula. Okay? Is that a little bit clearer, maybe? So now let me show you, though. We can use average value here. So now we're going to find the average velocity. Okay, so we're going to find the same thing, but in a different way, from the velocity function. Okay? Yeah. So what do I mean by that? Okay? So if we're going to find the average velocity from the velocity function, well, we've got to find the velocity function. So how do we find the velocity? What would the velocity function be, or how can we find that? Derivative of position function. F prime of t equals negative 32t plus 48. That's the velocity. Okay. Now that I have the velocity function, I want to find the average velocity. What should I use? Average rate of change or average value? Average value, because it's what we have. We have the velocity function. I want to find the average velocity, so I want to use average value. Okay. If I wanted to find the average acceleration, what would I do with this function? I could take the derivative and then use average value, or I could use average rate of change formula on this. I could do the f of, or v of, I could use the slope formula for it. Okay? So this is average velocity. So I want to find average velocity. I'm using velocity, so an average value formula. So 1 over b minus a, so 3 minus 1, times the integral from 1 to 3 of negative 32 t plus 48. Okay. So again, this is two different ways to find the same thing. Two different ways to find the same thing. Okay, so let's see here. So let's see, it's going to become 1/2. I'll go ahead and integrate this too. So integral of negative 32t is negative 16t squared plus 48t. And we're going to evaluate that from 1 to 3. Okay, and so let's see here, it's 1/2, and so we negative 16 times 3 squared plus 48 times 3 minus, and I guess put this in like square brackets here, minus the quantity negative 16 times 1 squared plus 48 times 1. Okay, so again, just evaluating it, it's evaluating the normal definite integral there. So let's see, we get 1/2, and then 3 cubed is 9. 9 times negative 16 is negative 144.
Yeah.
3 times 48 is
48,
also 144. Wow, that's kind of nice. Minus, and then let's see here, negative 16 plus 48 is 32. And so this becomes 1/2 times negative 32, which is negative 16 feet per second, the exact same answer we got up there, right? Which it is, well, it shouldn't be crazy though, right?
Makes sense.
It should be the same thing because we were finding the exact same thing, just two different ways. All right? So, I feel like I maybe made things more confusing by showing you these two different things, but, well, there it is, okay? The idea is that you have two different things that you use to find an average of something in calculus. We have average rate of change, we have average value, okay? Depending on what initial information you are given, you're either going to use average rate of change formula or average value formula, all right? So let's take a look at another one here, all right? And this will be it, actually, after this one. Yeah?
Does average value only work in closed interval?
You only normally find the average value in a closed interval, yeah. All right, so So try this one, okay? So a store creates a model to fit the monthly sales of their top selling product. Oh gosh, right. Out of sight, out of mime.
I'm confused. Is that the name of the product?
What?
I'm just gonna say product.
A street performer repellent.
It's at this point that I stop writing the context for the problem.
Right.
Although I do appreciate it.
Who writes these?
My roommate wrote this problem, and he really does not like street performers. They annoy him.
Did he have like a bad experience as a child or something?
No, I think he just like doesn't like the fact that they're trying to like be something that they're not.
Yeah, that's true.
So sometimes, and actually, like I will say, he was like, I need a name for this product, and I was like, how about out of sight, out of mime, kind of thing. And he's like, oh, that's pretty good.
What's your roommate do?
He's a calculus teacher at Oakdale.
Do you guys like
Nerds.
do you have a bunch of math memorabilia in your
We ever like make
apartment?
songs like I bet you can so much.
Yes, sadly, they're life problems.
Do you compare
I'm just kidding.
do you compare your students' grades to see which one of you is the better?
No, because he destroys me.
Oh, that's not good. That means-
No, it's no, he teaches ABBC too, so it's different. It's different.
Do you know ABBC calculus?
Yeah, up to about sequences and series, and then I kind of I fall off here. Oh shoot, I'm gonna run out of space. That's right.
And then we can all get back grades on our test.
Yay!
So if you took Miss Steinfeld's class, do you think you would get a good grade at the end?
Oh yeah, no problem. If I took the class, yes. If I was given the test right now, then I would maybe get a 3 on it.
So when you went to college, did you like? So do you have to?
That's a pi t over 6, by the way, here.
Not on those
Can't see
things.
it.
Also, in college, did you like get to pick courses that would enable you to either teach just AB or like ABBC? Like, how does that work? It's like if you want to teach
In
ABBC,
college,
go to these classes.
no. In college, I was a double major, which was required at University of Maryland if you wanted to teach like at the secondary level, that is high school, right? So you have to both major in education and major in whatever your content area is. So I was a math and secondary education major, which means I took all the same classes a regular math major did, except for like one less math elective because, you know, I had not much room in my schedule because of all the other education classes I took. So, James' question. It's pi t over 6. Pi t over 6. Sine of pi t over 6.
All I really need is this.
So anyway, so I had to take Calc 1, Calc 2, Calc 3, linear algebra, differential equations, I'm trying to think of other stuff. I mean, and then some other like math electives and stuff like that. What's that? Proving calculus, the worst class I ever took in my life, yes. Yeah. Oh, let's talk about that when it's closer to Pi Day. But sure. Okay, what? So, yes, you prove how you find those derivatives and stuff like that, rather than just saying, oh, it works out, look at that, you know, kind of thing. I can show you. There's actually some in the book and stuff like that. I can show you what they look like, and they're not. I still don't understand to this day.
I would like to see. That sounds
So,
interesting.
yeah, I can do that. Anyway, so let's get back on track here, though. So we have this model for the monthly sales of this top-selling product, okay? And it's over the interval 0 less than or equal to t less than or equal to 24. S is the sales in thousands. T is time
In years?
in months.
Ooh.
Yes. Sorry, I didn't do a very good job. I'll rewrite the formula up, the function up on the board too, because I didn't do a very good job writing it out. Okay. Find the average sales for the product over the 2 years. Okay. Find the average sales for the product over the 2 years. All right. So there's that word average. Okay. We want to find the average sales for the product over the 2 years. What are we given? What is this S representing?
Sales in thousands.
Sales in thousands over per month for months. All right. T is time in months. Okay. So if I'm given the sales function and I want to find the average sales, am I using the 1 over b minus a times the integral from a to b, or am I using f of b minus f of a over b minus a? I am using the second one here. Okay, this one that I mentioned first. Okay, this one right here. Yes. Okay. It is.
Which means we have to take the derivative.
Do we need to take the derivative?
You mean the integral?
No, we're going to integrate. And by the way, you may use a calculator for this.
Oh,
Yeah.
Okay.
Okay, here we go.
Why are we using the bottom one, the second one here? We're using this one because of what we are given. The function that we're given here is the sales. We want to find the average sales. So given sales, and we want to find the average sales, that means we want to find the average value of the sales. Okay? If I gave you the sales and I said, what's the average rate of change of the sales? Then you use f of b minus f of a over b minus a. Okay? Just like up here, I gave you a position function. Okay, and I wanted you to find the average velocity. Well, if I gave you the position, I want you to find average velocity. Well, velocity is the rate of change of the position. So instead of saying average velocity, I could have just said average rate of change of position, which means we need the average rate of change formula. Okay. Alternative, though, since I have the position function, I could take the derivative to get the velocity function. Follow me so far? And then to find the average velocity using the velocity function. So find average velocity using velocity. I would then use the average value because they're at the same kind of level, if that makes sense. Okay, so given sales, finding average sales, they're on the same level. Sales, and we find the average of those sales, so that's the 1 over b minus a integral from a to b. But then, given position and asked to find average velocity, those are not at the same level, right? Velocity is derivative position, so that's the average rate of change.
1 over b minus
Okay. So that's why we did average rate of change to the first part here, and then we manipulate things to be able to do the average rate
Well,
of
I'm thinking
change.
something
Average
like
velocity,
multiply
average
by
value. Okay, so go ahead and do that real quick. You may use your calculators.
No, this was a per month.
Okay. So I'll come around and kind of help. I would suggest you set up your integral first. All right, set up that integral first, and then you may use your calculator. So, yep.
You know how like stay on the same level and like go up a level?
We don't know how to find the average value of something like up. No. How to find the average of something like above. No.
So,
Like if I gave you a velocity function, you wouldn't be able to find average position from that using the velocity. You have to like integrate the velocity and get some information.
Yeah, I think it's possible that you go by quicker and just have that as third block.
Okay, so y
goes by
from
slower.
0 to 2.
Yep.
starting at the first year.
First 2 years. What is t in what are the units for t though? Months. So it would be 0. Yeah.
I'm tired. Third block is always like the longest.
So,
Yeah.
so you would do that?
Yes.
Question.
Put that on.
So our answer should be in scale per month then?
Well, again,
I know it references years, but sales per month, no, yes?
it should be just thousands of sales. Should be thousands of sales.
Okay, so it's not a per monthly basis?
So
That's just
multiply
like
by
the average of the entire thing?
Yes.
So multiply by 24 at the end.
Well. Now I'm wondering.
And that over 2 years in months.
Well, yeah, but...
No, yeah, that would be per month then, I guess. Thousands
Yeah.
of sales. Yeah, 1,000 sales per month.
Hence
Yeah.
the multiplying
Dividing by
yeah.
dividing by the 24 there. Yeah.
Okay.
And then that's not necessarily dollar value though, is that like number of physical sales, I guess?
No, actually not per month then. It would just be 1,000 sales.
Okay.
Yes, but I guess it is kind of like a per month thing. But like when you do the average of data, you don't say like per thing though. You just say. So I just say that it's just 1,000 sales. It should just be the units, the same units as the original thing. So yeah, thousands of sales. Yeah.
So then, is this correct?
6.55.
Yeah.
Yeah.
But then 1,000 supposed to be 6,500.
Is there a way you take the derivative?
So again, why would you think you need to take the derivative here?
I don't know if Jack said you could take the derivative.
So
He said we
Why not
didn't.
using the
these are at the same level, right? I want to find, I'm given the sales function. I want to find the average sales. So it's just average value. I can't. These are at the same level. You just do it. It would be like.
There you go.
Okay. It's at the same
Yours is
level, so you
little-
just take the average value. I'm right there, James.
I changed your schedule. Okay, good.
Yeah. That's it. Yeah. What are the units though for that?
Money,
Right. That's
That's
right, you are defining, but keep in mind though, what are you finding? It says find the average sales. Number of, yeah, not in dollars, it's like how, like, I guess like one sale transaction. I think it's not like in dollars. Or actually, wait a minute, is it? No, I think it's just number of sales, same, yeah.
Every boy is gonna know.
Thousand. Right, because it's in thousand. So you can find 1,000 sales units, or you can say 56,550 sales. You understand what I'm
Hey, Ryan, you're not in the US, right?
So this is you are doing I think you're doing the average rate of change here.
It's a great song.
Okay, if you're doing are you going to do like
Actually,
FTC
not my
minus
grade.
A, B minus A? So that's you don't want to do
You guys
that
are
here
2%
because
You like
we
2%
are
stuff.
given the function
I apologize.
in
You
the
sound like
sales function.
sound like
We're going to find
really
the
upset.
average
It's just
sales. So that means I'm given sales, I'm going to average sales.
Yeah.
Bound.
No.
I put 1 over B minus A.
Oh.
I was giving you.
Look at what my calculator does.
If I give you the sales, then I ask you to find the average rate of change of the sales, then you do FD minus It's not, yes, it's complicated. It's not the easiest thing to wrap your head around. We'll get some more practice to iron that out, but yeah. Function, comma, x, comma, lower limit, comma, upper limit.
Would you get Austin? That's what I got. Wait, what's your, did you?
I don't know, Tyler. There's like so many things.
My calculator will literally just.
You didn't multiply by once before.
Yeah? Well, let me see if my calculator can do it. I'll use the same one. Okay, so here's what we should have for our setup. 1 over 24 minus 0. Okay? You might say to me, Mr. Whitmire, you said the first 2 years. I did say 2 years, but unfortunately, we are given t in terms of months. 24 months is 2 years, so 1 over 24 minus 0, we have to keep it in months, because that's what our t, our variable, is in terms of months. So yes, it's 2 years, but 24 months is the same thing as 2 years. And so we're going to do 1 over 24 minus 0, integral 0 to 24 of our crazy s of t function there. Okay, dt. Now my recommendation, if you have kind of like a calculator here without this, like the pretty type that you can do, I suggest you type it all in your y1. So that means, you know, x to the second divided by 4 plus 1.8 square root 2x plus 1 plus 0.74 sine of second pi x divided by 6. Type that in your y1, and then you go back to your home screen, math 9 for function, integration there. Vars, y bars function y1, comma x, comma 0, comma 24. So Anna, there's the setup right there. Okay, what you're asking about. All right, hit enter. Did yours ever actually calculate?
That'd be really cool. What?
Oh, mine did it.
You can look, if you press on, it will quit.
Right, it'll break it. Yeah.
You can look at my Y1, as my picture, right? Put it in.
I see 4x to the negative 2. Oh, it's x squared over 4. 4 times x to the negative 2. You want, no, because that will put the x in the denominator too.
Oh, I don't know why I wrote that down. That's weird.
Yeah, so it should be divided by 4. That might have been messing your calculator up. I don't know, I hit enter, we'll see. There might have been other stuff I didn't check to see. So there's that. Alright, but what do I still have to do to this number?
You gotta divide.
Divide by 24, right? Because it's 1 over 24 in front. So it's 1/24th of that 1,359.140, I guess I'll say. So divide by 24, 56. Oh, and I must have rounded that before I divided. 1357.2 is what I got before.
That's what I got on my calculator.
Alright, I just did
Maybe I took it in incorrectly here. T squared over 4, there's that, plus 1.8 square root of 2t plus 1, plus 0.74 sine of pi x over 6. Huh. Okay, so it should give you 56.55. I don't know why it didn't give me, excuse me, that.
it worked at a water bottle.
Okay, did you get, okay. Yeah, I don't know why I didn't get 1357.2, that's weird. Okay, well anyway, it should be 1357.2, and then that will equal 56.55, and what are the units for that?
Sales.
1,000 sales.
Yep, you're right.
Okay, which you can then rewrite if you wanted to, 56,550 sales. Okay, so either one of those is acceptable. Okay? Question?
If you didn't write it out, is it going to be
Like, did you write this?
like after the,
I'll come take a look at it. How about that? I'll come take a look at it. All right. So